Good afternoon, everyone. I'm Jiayu Li, a postdoc at the CBE. Today, I will share with you a study comparing air pollutant between gas and induction cooking and the effectiveness of a recirculating range-hood. This study was made possible by the teamwork of excellent colleagues at LBNL. So cooking is one of the great example of those things that we all do without thinking much about it. But it turns out when you cook, you produce a lot of gases and particles that mix into the air you breathe. Among those gases, carbon dioxide and methane are two major greenhouse gases. That can be from cooking with natural gas, and they are major. They play an important role on climate change. VOCs, including nitrogen dioxide, also can be from fuel combustion, which is a respiratory irritant. So VOCs, including many organic compounds, can be from both fuel combustion and the cooking food itself. They can cause both acute and chronic health issues. Fuel combustion and cooking also generate lots of particles in different sizes, such as ultrafine particles, PM2.5 and PM10, which cause a range of adverse health effects, with smaller particles posing greater risks because they can penetrate deeper into our body. Compared to gas cooking, which most of us use at home, induction provides us an alternative way to cook more efficiently, as induction can deliver more heat directly to the food. It can minimize the heat loss to the surrounding air, so it can provide a cooler kitchen environment. Induction cooking doesn't have an open flame, so it's safer and potentially healthier due to it can avoid the combustion-related pollutants. Currently, 3% of Americans have an induction appliance in their kitchen, but it's growing fast. 70% of people would consider induction for their next cooktops. And it has been growing in double digit over the 3 years in the sales market. Range-hood have been recommended for the mitigation solutions for cooking-related pollutants. Many studies have proven that venting range-hood are quite effective, as they directly remove the pollutant outdoors. However, for many houses, especially the old ones or the multi-family homes, cannot install the venting range-hood due to the limited capability of drilling holes on the walls. So the recirculating range-hood with the filter become the options for them. However, limited studies have shown whether it is effective or not. So in this project, we aim to compare the pollutant between gas cooking and induction cooking, and to check whether the recirculating range-hood are effective or not. We measure pollutant repetitively from repetitively cooking a simple meal in a controlled environment, the Flex Lab at LBNL. The study was funded by Building Technologies Office of the Department of Energy. So in the Flex Lab, we set up a stage for this comparison. the size of the chamber is similar to the area of the rooms with a kitchen in an apartment or a small house. The HVAC system was off during the cooking period, and we used fans to fully mix the air. To make sure of fire comparison, we matched the power input between gas and induction cooktops and carefully weighted the mass loss of the food material during the major cooking activities. We implemented the same cooking procedure 18 times, including 2 cooktop conditions times 3 rent hood conditions times 3 repeat. Our referees for this comparison are the scientific grade instrument that measure gases and particles with high accuracy and temporal resolutions. You can find a list of the instrument we used at end of the in the published paper at end of the presentation. So here is the result. In this page, 2 plot panels shows the result from nitrogen dioxide and the carbon dioxide. Within each panel, the exposure concentration was plotted as a bars with gas on the left and induction on the right. And the colors indicate the rent hood conditions. The p-value above the bars indicate the significance of the difference, the level of significance of the difference between these 2 groups. We can see that gas cooking produced significantly more nitrogen dioxide and carbon dioxide than induction. So particularly, induction cooking produced no discernible nitrogen dioxide. For particles, from the first panel, we can see that gas cooking produced way more ultrafine particles than gas cooking. For PM2.5 and PM10, on the middle and the red panels, we can see that induction cooking likely produced more PM mass than gas cooking. However, the result for PM2.5 and PM10 are not fixed. It means if we change the instrument to measure PM, or we cook a different meal, the result can be different. We have a very interesting discussion in the published paper. You can find it again at the end of the slides. For VOCs, among the 10 of the 16 detected compounds, it shows very similar trend between gas and induction cooking. And the 5 of them shows higher with gas cooking, and 1 was higher from induction cooking. This page summarizes the effectiveness of recirculating rent hood regarding lowering the particle pollutant exposure. From the first 3 pollutants on the left of the slide, we can see that both rent hood are quite effective on reduced particle exposure. However, for the VOCs, we can see that only 1 of the 2 tested hoods are effective. The hood A, as shown by the green dot, are all around 0. Hood B are quite effective for most of the VOCs, particularly for the PTEX compounds are the showed highest effectiveness, and the reduction for the alcohol compounds are least pronounced. So here's the quick summary of this study. For the nitrogen oxide, carbon dioxide, and ultrafine particles, induction cooking performed much better regarding the as the produced less these pollutants than gas cooking. For PM 2.5, the concentration for PM 2.5 and PM10, the concentration were likely higher when cooking with induction than with gas. For VOCs, the concentrations were similar in general, but it varies among those different chemicals. For recirculating brand food, for both of the tested food, we all see the quite effective regarding lowering the regarding particle removal, and one of the food showed significant effectiveness, lower VOCs. At the end of the slide, I want to mention our ongoing study ongoing field study in commercial kitchens. After we finished the chamber study, we have been visiting commercial kitchens in San Francisco Bay Area. In the field, we not only measure indoor air quality, but also thermal environment. We collect subjective feedbacks from kitchen staff and perform energy audit and ventilation assessment. The project is leading by Renji Chen at LBNL, and we are still recruiting kitchens. Please find more information in our project webpage. That's all for my presentation. Please let me know if you have any suggestions or questions.